Alright, Algebra 2 Trig Honors class. So let's talk about some of the probability continuation today. So today I would like to talk about 10.2, independent and dependent events. So whatever happens in one event has absolutely nothing to do with what will happen to the next. So that means the two events are unrelated, or you repeat an event with an item whose number will not change. So spinners or dice, or you repeat the same activity, but you replace the item that was removed. So the probability of two independent events, A and B, it's equal to the probability of event A times the probability of event B. So probability of A intersects event B, so that equals probability of A times the probability of B. So again, if two events are not related or unrelated, so we just want to find out the probability of each event separately, and then we just multiply them. Okay, so now let's look at the example. So the multiplication rule for independent events. So to get probability of both events occurring, multiply probability of individual events. So A's from first deck and spades from the second. So probability of A's is what? 4 over 52, 1 over 13, after you reduce it. And probability of getting a spade in the second deck, then that'll be 13 over 52, so 1/4. So the probability of both is 1 over 13 times 1 over 4. So then that'll be 1 over 52. And here's some practice problem. So roll a die and flip a coin. As you can see, that die and coin, they have nothing to do with each other. So those are two separated events. So the probability of getting the heads and 6. And the probability of getting tails and a 5. Okay, so let's find out. So it's 1/2 times 1/6, then that'll be 1/12. And then the other one, 1/2 times 1/6 also, getting the tail. Again, the head or the tail, the chance to get that is half, 50%. So 1/2 times 1/6, so it's what? 1 over 12 as well. Okay, so now what about a spinner? So let's say that suppose you spin each of these two spinners. So what's the probability of spinning an even number and evolve? Okay, so spin an even number, so the chances, then that'll be 3 over 6 or 1/2. Spinning a volve, then that'll be considered, well, how many volve right here? There's only one volve, so then that'll be 1 over 5. So get an even number and evolve, then that'll be 1/2 times 1/5. So 1/2 times 1/5, so let's find out, which is 1 over 10. And now here's another independent events examples. So find the probability of getting a jack and a factor of 12. Okay, so, and we're getting a jack here, so then that would be considered 1 over 5. And getting a factor of 12, so a factor of 12, according to the spin here, we do have what? 2, 3, 4, 6, 8. So 1, 2, 3, 4, 5 of those numbers are the factor of 12. So it's 5 over 8. So 1/5 times 5 over 8. Cross cancel, so we got 1 over 8. Again, if two events are not related, so we just multiply the probability of each event. Okay? So it's 5 over 40. Reduce it, it's 1/8. So probability of getting 6 and not 5. Okay, so probability of getting 6 and not 5. So getting 6 is what? 1 over 6 and not 5. So that means the second die would be what? 5 over 6. So it's 5 over 36. So now what about for the dependent event? So what happened during the second event depends on what happened on the first event. In other words, the results of the second event will change because of what happened of the first event. Determining the probability of a dependent event, it's usually more complicated than finding the probability of the independent event. Indeed, yes. So the probability of two dependent events, A and B, it's equal to the probability of event A times the probability of event B. However, the probability of event B now depends on probability of event A. Okay, so what that means, so this one, for one of the examples, so two cards are selected from a production line of 12 where 5 are defective, and find the probability both cards are defective. So for the first event, we need to choose one of the defective cards, so then that'll be 5 out of 12, 5 over 12. And then the second card is defective, then that'll be 4 over 11. But the reason why that is because we select one card already from those 5. And also for the possible outcome, so we also select one card, so that's why we need to subtract that by 1. So 5 minus 1, so we get 4. 12 minus 1, we got 11. So one card is already being selected. So that's why the numerator and the denominator of the structure of the probability, so they're both considered subtracting 1. So for this event, so for the event B here, so given that A, so we got 4 over 11. So 5 over 12 times 4 over 11, so we do have 5 over 33. So it's 0.1515. Okay, so independent event, spinner number 1 is partitioned into 3 equal sections. So color black, white, and gray. Spinner number 2 is partitioned into 4 equal sections, color red, blue, and green, and yellow. If both spinner are spun, what's the probability of getting black and red? So this one would be considered independent event because we do have two spinners, two different spinner. So one is partitioned into 3 equal portion, and the other one is partitioned into 4 equal portion. So the way to find out the probability of getting a black and red, so then that'll be considered 1/3 times 1/4. So it's 1 over 12. So got to be careful with the difference of dependent and independent events for the probability. And here's the one for the dependent events. A bag contains 10 marbles, 5 red, 3 blue, and 2 silver. If you draw one marble at random and hold it in your left hand, and then draw a second marble at random and hold it in your right hand. So what is the probability that you're holding 2 silver marble? So it's easier to determine the probability of the first marble being silver. However, notice that if you started by getting a silver marble and then try for the second, then the bag would be different. So now to look at that right here. Because that once you pick one silver, you're not going to put it back to the back. Okay, so that's why it's considered 2 over 10, 2 silver marble out of the total 10 marbles. Since you picked one already, you're not going to put it back to the back there. And the other one would be considered 1 over 9. So 1/5 times 1 over 9, because 2 over 10 is considered 1/5 after you reduce. So it's 1 over 45. And here's another one. So there are 6 black pens and a blue pen in a jar. If you take a pen without looking and then take another pen without replacing the first, key phrase, without replacing, dependent event. So what is the probability that you will get 2 black pens? Okay, so the first one, 6 over 14, or 3 over 7. And then the second one, 5 over 13. So therefore, multiply those two numbers. 3 over 7 times 5 over 13. So then that'll be 15 over 91. And here's another one. So find the probability. So all the letters of the alphabet are in the back in one time, and do not replace the letter. Okay. So that intersections means and. So and means multiply. Okay, so that's just another examples. So 1 over 26, and then times 0 over 25. So let's see what the condition here. Find the probability of Q and U. Well, Q and Q. Well, there's only one letter Q. Okay, so Q and Q. So the first one is 1 over 26, and the second one is what? 0 over 25. So there's no such probability for this. So the chances, 0. Okay? And this one is just going back to the first sections, 10.1, so we're not doing that. Okay, so now, that's it for the end of the video here. So any questions, concerns, so please just rewatch the video, or just fast forward, or just rewind to the part that you're getting struggle. Make sure that you know the difference, independent, dependent events for the probability. Okay, so I'll see you guys next time. Take care.